Okay, so we're going to prove side similarity in this case. In this case, what you have is that the sides are in proportion, and going off of that, what you want to show is that then the triangles are similar. Now, to do this, you basically just take this triangle ABC, and you should convince yourself that these two triangles, if they're congruent, then the statement is true. So if they're not congruent, right, then that means that one triangle is smaller than the other. So let's assume that DEF is smaller than ABC. Now, what I'm going to do is I'm going to compare AB and its corresponding side DE. So AB lies along here, right? What that means is that then I want to pick that side to pick some P, right? Where PB is congruent to DE. And I could always do that, right? Now, again, as long as it is that the two triangles are not exactly the same, in which case they're congruent and then therefore similar, one triangle will be smaller than the other. So let's say that DEF is smaller than ABC. That means that in its corresponding side AB, there's going to be some point P where PB is exactly the same length as DE. Now, I found that point P, and what I do is that I can always draw a line that is parallel to AC as so. And I'm going to call this other point Q over here. Now, once we have this fact, right, so what do we have so far? We have PB is congruent to DE by my construction. And I also have that PQ is parallel with AC by my construction. Now, and also the given here, but we'll use that in a second. But now, well, what do I have? If it's the case, right, that these two lines are parallel, PQ and AC, this immediately is going to give me that. Let's call this, I don't know, angle 1 and angle 2, right? Angle 1 is congruent to angle 2 because they're corresponding, right? Corresponding angles. Angles axiom. And then you could also say that, whatever angle this is congruent to that one, but you don't even need that. They both share this angle up here, so I'm going to say angle B is congruent to itself. And then these two things imply that triangle PBQ is similar to triangle, if that doesn't happen once in every video, okay, is similar to triangle PBQ ABC, right? By angle similarity. And now, once you have that, you know that if the two triangles are similar, that their sides are in proportion. So I'm going to write the proportionality statement from this fact, right? I know that the triangles are similar. I know that their sides are in proportion. So I have that AB over PB is equal to BC over BQ over BQ is equal to AC over PQ. Now, if we look at this one with what's given, so let's write down what's given. The given is this statement, right? That the sides of these two triangles, the original two triangles, are in proportion. So AB over DE is equal to BC over EF is equal to AC over DF. Now, with these two and one other fact that these two things are congruent, which means that their lengths are equal, and you write that their lengths are equal as PB is equal to DE by definition of congruent. So I have that PB is equal to DE, right? So in this one, if we look, AB over PB, we know that this is going to be equal to AB over DE. And this forms a chain. Once you have that chain, right, this AB over PB is equal to AB over DE because these two things are equal. Right, PB is the same thing as DE. So instead of writing PB, I could write DE, and now I have an equality here. And once you have that, that links you to here. And the link here gives you everything that you need, because now you have that all of these things are equal. All of them are equal, okay? So we have that BC, right? So AB over PB is equal to AB over DE, right? And AB over PB is equal to BC over BQ. So then now BC over BQ is going to be equal to BC over EF. So just follow along with how I got that one, right? But then simultaneously, I'm just going to write it as a new equality because this first statement is going to give me one thing, and then what I'm about to write is also true. So look, again, okay, let's see how I link everything together. This is the same as this. And then this is over here, which is the same as this and this. So that's essentially saying everything is the same now. So you can take any of these ratios and set any of the other one equal to any of the other ones. So I just took this one and I took this one and I set them equal to each other. And it's going to give me a nice fact. And then the next one that I'm going to say is that AC over PQ is equal to AC over DF. So these two things, right? This one, what does this one imply? This one we should see immediately implies, right? BC is the same as BC. So this one implies, if you just do a little bit of algebra, which isn't necessary, is that BQ is equal to BF. Okay, and then this one implies that PQ is equal to DF. And this is what you need, because this, right, this is the definition of congruent. BQ is congruent to EF. And then, of course, by the definition of congruent again, I don't know how necessary you guys feel this is at this point. DF, right, these two segments are congruent, these two segments are congruent. And what did I have? I had by construction that PB was congruent to DE. So now let's look at our triangles. So I said, what is said over here? What's said over here is that BQ, this segment, is congruent to EF. And then I said that DF, this one, is congruent to PQ. This is this one, right? So now I have that these two triangles are congruent by side, side, side. So I have that triangle PBQ is congruent to triangle DEF by side, side, side. Congruence. Okay, congruence. Now, if these two triangles are congruent, right, then they're similar. So I know that they're similar, and I know that PBQ is similar to triangle ABC. Therefore, by transitivity of similarity, transitivity of similarity, right? Did I mess up? Nope. Of similarity, I have triangle DEF is similar to triangle ABC. And you're done.